Welcome again to Xlex and this video clip. My name is Hannes Schweiger from Miran Roser in Graz, Austria. Today I would like to introduce and welcome the fifth interview partner in this row of a series of interviews, talking to all 12 project partners of this Horizon 2020 project. I'm now connected with ELEKTRO CELJE, which is a local energy provider in Slovenia. And on behalf of the project team in Xlex, I would like to welcome Dr. Miran Roser. Dr. Roser is electrical engineer, works for ELEKTRO CELJE since 1982, and is responsible for the introduction of modern technologies as a basis for smart grids. Hello, Miran, and welcome. Nice to meet you.
Hello, thank you. Yes, my name is Miran Roser and I work at ElectroCelje in the development and operations department. I have almost 39 years of experience in the DSO system, and I mainly deal with control, operation and protection. And for the last 10 years, I have intensively worked with new technologies, also known as smart grid solutions. Otherwise, like you mentioned, ElectroCelje is one of the 5 DSO in Slovenia. We establish and maintain the infrastructure which supplies more than 170,000 customers. Our vision and mission is to improve the energy supply quality and to decrease outages in all domains within the scope of ElectroCelje. Last but not least, we are aware of the enormous changes that will impact the grid regarding renewable resources. This is already happening, and I can mention that a project like Xlex could help us a lot, especially in implementing new technologies like battery storage, for example.
Okay. What would you say? What is your specific role in the project, and in which tasks and work are you involved in Xlex?
Such a complex project needs to be handled carefully. Therefore, we were forming a team mainly responsible for supporting Xlex projects and also partners' needs. So to answer our specific role, let me note that we manage the real distribution network. Therefore, we have a live polygon with real challenges and operation requirements. This is on the one hand quite a demanding task, but on the other, it's an excellent opportunity to research how newly available technologies could fit in. We are quite deeply involved in Work Package 7, mainly concerning the pilot operation. The pilot site Luče represents an example of a region connected to a relatively weak medium voltage feeder. So the outages, especially during bad weather conditions, are quite often. Therefore, in the Xlex, we address this issue with the operation of the low voltage battery storage. Moreover, there are also weak lines on the low voltage side of transformer station Luče. However, those lines supply customers with a significant share of installed photovoltaics. So one of the questions addressed in the Xlex is how to increase the share of photovoltaics resources without substantial retrofit expenses.
Could you briefly tell us the lessons you learned so far in this first years of the project duration, and what are your next steps and expectations for the results of your work?
Okay, the Xlex slowly enters the period of the final year. If I try to pinpoint the lessons learned, I should highlight 2 of them. First, implementing the new technology like battery storage into the real system is quite a comprehensive task. There are a lot of challenges because there is a wide open issue concerning the security of the operation of such equipment. The second lesson is that despite all the partners striving to manage solutions as simply as possible, this is not always the case. The reality is that even though all developed solutions based on computer technologies and as such should be used by persons at the end of the day. And this is a process that is sometimes quite a time consumable and challenging. About our next step, we learned that with battery systems harmonized through the home energy management systems, it is possible to push the existing system beyond the so far known limit. Therefore, we expect that with the lowering price and increased robustness of such solutions, we could widely use them in the DSO low voltage system.
Last but not least, what is your expected benefit and impact of your role? And what are your specific plans in exploiting the results of Xlex? in Slovenia?
Well, the expected benefits are, for example, better utilization of the existing equipment without upgrading existing equipment, and we can expose increased supply stability, especially in regions prone to outages during bad weather conditions or weak supply lines in the rural areas. Then we can talk about the improved voltage profile, especially when all renewables try to inject all available electrical energy into the DSO network. Regarding or about the plans for how to exploit the results of XFlex, we plan to incorporate market flex mechanisms so that we will try to use available flexibility in the low voltage system. We also plan to scale up the semaphore mechanisms developed in XFlex because it is indispensable to safely and efficiently exploit flexibility mechanisms. Last but not least, we learned a lot about the island operation of the battery systems on the Luče pilot site. We met the potential of such an operation, which offers a possible solution to increase the quality of supply for remote and rural places covered by the DSO.
Well, Miran, thanks for joining and this information you provided here and today. Again, if you want to know more about the project, please go to the website and the link given below. Thanks for watching and see you soon at the next upcoming interviews with other project partners of XFlex. Thank you very much and bye-bye.
Thank you very much. Bye.